to hear Mr. Gonzalo. He is a textile engineer and co-founder of Provita, and he is from Argentina. The company is also based in Argentina, and I think he will definitely speak more about himself and the company as we go ahead. We also have Dr. Arun Kumar Patra, who will take care of our Q&A. So Professor Patra is from India. He's a professor in textile chemistry. So I think he is somebody who can handle the Q&A properly, right? If there are any questions, and he can basically understand those questions and get the correct answers from you, okay? So because he has very good fundamentals in chemistry. So definitely he's the right person to handle those things. And we also have Dr. Graham Clayton, who is the CEO of SDC, Society of Dyes and Colorists. And just to inform everybody, Society of Dyes and Colorists is based in Bradford in UK. We are 140-year-old. Yeah, and that's Dr. Graham. So we are a 140-year-old organization. We are involved with the ISO standards and the color index numbers. We also do the color competition for the design students. So this year it will be in Singapore, ITMA Asia. So I think somebody from Gonzalo's team would be there. So if they can see participate in the design competition, and also anybody from the audience, if they are going to ITMA Asia, they can please attend our competition and meet Dr. Graham there. He will be at our booth, since we are the members of the British Textile Manufacturing Association, Machinery Association. So with I'm not coming between you and your audience. So Gonzalo, you can start. Okay. Thank you very much.
Thank you. Well, good morning, good afternoon, or good evening, depending on where you are joining from today. For me in Argentina, it's 6:30 a.m., so I'm happy to start my day with you all. Thanks to the Society of Dyers and Colorists, and in particular to Mr. Yogesh for having me here. It's truly an honor to speak to fellow textile professionals, chemists, engineers, and designers, a room full of people who really care about color. I am Gonzalo Pulca, co-founder of Protiva, and today we are going to explore how bio-based dyes can transform the textile dyeing process. Our agenda for today will cover industry background and textile market context, Protiva's bio-based solutions, commercial strategy and climate impact, the team and the roadmap, and partnership opportunities. Please feel free to drop your questions in the chat box as we go. I will be checking after each section. And okay, now allow me to start with a little story about how biology is meeting the textile industry. A few years ago, Esteban, the visionary behind this venture, was a biology student contemplating his final project. He grew up in a small town in southern Buenos Aires, Argentina, where a textile mill was the main business. A visit to that mill left him with a lasting impression, the striking colors and sharp odors of its effluent. That moment sparked a powerful thought, and he thought, there must be a better way to make colors. This question ignited his research into bacteria that naturally produce colors. Over the time, the project began to flourish. Emilia, a biologist, and Carola, a biotechnologist, joined the team, ready to elevate the idea to the next level. In a certain moment, they had the bacteria, they had the colors, but they realized they need a textile engineer with experience in a textile mill. And that's precisely when I entered to the team, all thanks to a LinkedIn search. So what began as an after-office hard work and weekend experiments in a house garage has evolved into what we are today, Protiva, a biotech company developing bio-based solutions for textile dye. Now that we have introduced Protiva, let's turn our attention into the evolution of textile dyes and their impact. The modern chemical dye industry was born from an accident. In 1856, Sir William Perkin was attempting to synthesize quinine, a cure for paludism. Inadvertently, he discovered the first synthetic dye, mauve ink. This accidental purple revolutionized dyeing in a time when colors came primarily from plants and insects. From that moment, the industry rapidly developed more and more sophisticated molecules, and we will progress far from early aniline dyes to the reactive dyes we use today, which offer unparalleled fastness and more vibrant colors than even before. However, even though performance has improved dramatically, the fundamental way we make dyes hasn't changed in over 150 years. We are still synthesizing them like Perkin did, starting with fossil fuel-based petrochemical reactions, which generate hazardous byproducts and discharge pollutants into our water systems. I'm not saying this was a mistake, quite the opposite. This technology enabled the industry to grow on a massive scale. But this same technology now presents a gigantic climate problem. The current textile industry consumes more than 700,000 tons of dyes annually. If we estimate an average of 80% of exhaustion, we are saying that more than 140,000 tons of petrochemical derived dyes goes directly to water effluents. Apart from that, according to an H&M Foundation and Accenture report, over 50% of all pollution from the textile industry comes from just one stage, the dyeing process. It's in this process where we consume the most water, energy, and chemical of the entire supply chain. This is why dyeing is key to rethinking how we produce our textiles. Now, let's look at the textile market landscape. The fashion market is projected to grow 7% CAGR by 2030. If nothing changes, this growth inevitably means that the environmental impact will continue to rise. However, various reports indicate that the sustainable fashion market will grow by a remarkable 23%, clearly demonstrating a strong trend toward more sustainable practices and products. That's why more brands and manufacturers are choosing to certify their products and processes under standards that eliminate hazardous chemicals or certify organic components. The industry is doing this not just to meet regulations, but also to satisfy a growing consuming demand for cleaner and safer textiles. If we center on the global dye market, most synthetic dyes are produced in China and India and shipped all over the world. This creates long lead times, price fluctuations, fragile supply chains, and a massive logistic footprint as products crisscross the globe. Consequently, brands are increasingly pushing for nearshoring strategies, in other words, producing closer to consumption centers, to build more resilient and sustainable supply chains. Okay, and what about, until here we have any question about the market? Let me check the box. No, we are good. Okay, let's talk about green alternatives. For us, it's not about synthetic products being bad versus naturals being good. We prefer to talk about hazardous and safe processes. For example, when we consider current dyeing processes, we know they are highly efficient in terms of color intensity, repeatability, and durability. However, as we talked before, they fall short due to toxic byproducts and effluents, making them hazardous. On the other hand, while safe processes focus on being eco-friendly, they often lack efficient solutions for the mass market. They can be inconsistent, offer weak color fastness, and if we are talking specifically about plant-based dyes, many are not scalable because they demand farmland that could be used for food production. However, in recent years, new alternatives have emerged with the potential to truly transform textile dye. There is a real opportunity to offer processes that are not only sustainable, but also scalable and biodegradable. We are talking about bio-based dyes. As you can see, there are about 15 startups around the world working with microorganisms to produce dyes using different species, from plants, algae, bacteria, to engineered yeast. The oldest among these companies is 10 years old, which shows just how novel this science is. They also vary widely in their technology, base, target markets, and business models. But we are here to talk about Provita and how we differentiate ourselves in this competitive landscape. In Provita, we are developing industry-centered, bio-based, and chem-enhanced dyes. Why do we call it industry-centered? We call our approach industry-centered because after extensive discussions with textile mills, engineers, brand designers, and big players of the industry, we understood that simply being eco-friendly is not enough. The next generation of dyes must also be efficient and meet high-performance standards. With these crucial insights, we've defined 6 key metrics to validate our solutions. First, cost efficiency. This is the gateway to entering the industry. Without it, there is no business here. We see in biotechnology and in our own technological approach a unique opportunity to achieve it. For us, cost efficiency means combining low-cost production with high performance in application. And we know how to get there. Second, dye load. We aim to achieve the same color intensity as a synthetic dye using the same amount of our bio-based dye. Together, cost efficiency and dye load determine the dyeing process cost in dollar per kilogram of fabric. Our metric number 3 is clean dyeing processes. This metric summarizes the savings in water, energy, auxiliary chemicals, and effluent treatment. In other words, it represents the opportunity to decarbonize and detoxify the dyeing process. Fourth, color intensity. This is an interesting metric because achieving high color intensity is not easy with traditional natural dyes. This represents a significant opportunity for us to differentiate Provita from other green alternatives. Combining the dose of colorants, clean dyeing process, and color intensity give us the color performance. Number 5, sunlight fastness. This is another key metric where natural dyes commonly fail. And last, but certainly not least, wash fastness. There is no high performance if our dye bleeds in the washing machine. Of course, these 2 key color fastness metrics together determine color durability. Now, let me explain how we are addressing each of these metrics with our technology. We develop bio-based dyes produced by extremophile bacteria. This bacteria lives in the most extreme ecosystems of Latin America, enduring strong sun radiation, high temperatures, and extreme pH levels. Yes, we go to the most extreme environments to find natural colors. It's a big effort, but there we can find natural resistant colors. They naturally produce pigments that protect these bacteria from this hard condition. We leverage this natural resilience to make our dyes resistant enough for industrial processes. Once we isolate these bacteria, we grow them in fermenters, also known as bioreactors. This technology allows us to scale our production to industrial volumes without risks or to cost or to space. Then we stack the natural pigment and test them in the textile lab to see how they meet our key metrics. First, cost efficiency. Their high productivity allows us to produce high concentration of pigments in bioreactors. These production strategies benefit from economies of scale. The larger the scale, the lower the cost. Biodegradability. Since these pigments are natural, they are inherently biodegradable and much easier to treat in effluents. UV resistant, because these bacteria evolved to withstand high UV radiation, their pigments are naturally light-fast, giving us a clear advantage in dye durability. But here is the truth. Nature is not enough. We need to enhance it. And as you well know, no single dye works the same for all textile materials. Therefore, we enhance our colors using green chemistry to make them compatible with each fiber type and application. Green chemistry is a modern approach to designing chemical processes and products that minimize harm to the environment and to human health. It's guided by 12 principles which focus on preventing pollution by using safer, non-toxic materials, reducing byproducts, waste, and energy consumption, and maximizing the efficiency of every reaction. With this approach, we've developed a methodology to accelerate our dye research and development. First, we start by designing and engineering molecular modifications to improve bonding with key textile fibers and our dyes, all while preserving the biodegradability and sustainability of the process. Then, we feed experimental lab data into an AI engine that learns and predicts the outcomes of targeted chemical changes. This allows us to accelerate our R&D cycles, delivering optimized dyes with high performance. By applying the green chemistry approach and this R&D cycle, we modify our pigments to achieve the next key metrics. Intense colors, number 4, with the same dye load that synthetics, number 2, and strong bonding to achieve wash resistance, number 6. We are currently validating this approach with our first MVP, a bio-based brown color. It's worth mentioning that these initial performance results are based on a non-chemically enhanced application over wool fiber. We are actively developing the enhancement in the lab, and we don't have public results for that path just yet. But these few results show, first, cost efficiency reflects our current lab scale production. However, optimizations and scale-up are already underway. We achieved this hue with a similar dye dose to synthetics, and in the dyeing process, we only use chemicals to adjust the pH, no other auxiliaries. We also use wool traditional dyeing temperature, but have the typical industrial time to get an equal mid-tone brown. Both sunlight fastness and wash fastness were evaluated under ISO norms and showed acceptable results compared to the industrial standards. These metrics clearly indicate there is still a lot of work to do, but we are definitely starting from a solid stage. We already have real results in several textile fibers and applications, showing a very promising starting point with the dye's natural state. We've tested our dyes on 4 main applications. Wool fabrics, as we have seen, our most advanced results are on wool. This is because the dye molecule is more attractive to protein fibers. Cotton fabrics, we've tested on our dye on different cotton fabrics. For example, in this case, a shoe canvas, as you can see, we have achieved medium intensity with dye fastness and wash fastness comparable to wool results. Leather. Since leather is also a protein-based material, we try our pigments and obtain a beige colors with a low dose of colorant. And as a printing ink, we've achieved a high color intensity similar to synthetic pigments with the same load. We also saw good adhesion to the substrate, uniform prints, and stable color under light exposure and after washing. It's crucial to highlight again, these results were achieved without auxiliaries in the dyeing processes and without any green chemical enhancement just yet. Okay, so we don't have any question, right? I don't think so. Okay, with these results, we are not just validating a potential product. We are validating a production system designed to be scalable, cost-effective, and industrially efficient. This offers a feasible way to bring biotechnology isolation and production to provide sustainable dyes for every textile material in textile industry. With these solutions, we are offering a traceable system to help the industry decarbonize and detoxify the market, proposing differentiation to brands that could then offer toxic-free products, easy nearshoring production with no capex investment required, and drop-in solutions for textile mills and printing companies. Yay, Yogesh.
When you do fermentation, do you use any chemicals in the fermentation?
The fermentation is a natural process. We use some inputs, but they are all natural inputs to feed the bacteria, but anymore.
Okay, thank you.
You're welcome. Okay, so right now we are running pilot programs in mills, tanneries, and companies across Latin America, focusing on sustainable driven fashion brands, the ones most eager to adopt new green technologies. And the evidence is clear. We are already moving into scale-up commercial capsules, setting the stage for sales. These pilot programs allows us to test our solutions in various production environments with different machines and industrial conditions. We are learning how our dyes and pigments behave under real-world constraints, and this feedback is invaluable for us to refining our products. Beyond testing, these pilot programs also demonstrate a real market interest in our products. This can be evidenced by a letter of intention, for example, detailing the quantity and results required by the client. And if the pilot program goes well for both parties, it could even lead to a commercial capsule to establish a formal sales agreement. Talking about the commercial side, this technology will allow us to produce our products in every strategical region of the world. This facilitates nearshoring commercialization, significantly reducing cost and logistic challenges and footprint. This is feasible thanks to specialized production centers called CMOs, or contract manufacturing organizations. A CMO is essentially a company that other businesses hire to produce their products in their facilities. In biotechnology, CMOs specialize in manufacturing biological products, such as fermentation-based materials, leveraging their advantage facilities and expertise to produce this kind of products. In the near future, this nearshoring approach strategy will enable us to produce close to our primary clients. Operating on a B2B model, we will supply mills just as the industry currently functions. We also have to keep in mind that brands are the key decision maker here in the supply chain. They understand the market demand for sustainable products and are actively seeking for green alternatives. So we'll enter as a technological partner to deliver real and sustainable solutions throughout the entire chain. This leads us to a fundamental question. How much environmental impact can we actually reduce by switching from the traditional dyeing process to bio-based solutions? The traditional dyeing industry impacts the environment at three key stages: dye production, dyeing process, and effluent treatment. First, synthetic dyes are made from fossil-based aromatics through high energy and toxic synthesis. Then, the dyeing process requires large volumes of hot water, salts, and chemicals, with a significant portion of the dye washed away. As a result, the wastewater is loaded with persistent pollutants and compounds that are difficult to treat. The Provita bio-based solutions tackles all three stages. We use renewable feedstocks to grow bacteria and produce pigments through mild fermentations in closed bioreactors and without any toxic inputs. Our dyeing process runs at lower temperatures, requires less energy, and eliminates the need for harsh auxiliaries. all without compromising performance. And since the dyes are biodegradable, they are significantly easier to treat in the wastewater systems. When we reach the ambitious goals we've set with this bio-based approach, we expect to unlock significantly in environmental improvements across the full textile dyeing life cycle. We are saying over 40% in water savings per kilogram of fabric, more than 65% reduction in hazardous chemicals and auxiliaries, and up to 60% reduction in the total climate impact. This holistic improvement could redefine the environmental footprint of textile coloration without compromising cost efficiency or performance. As I presented at the beginning, Protiva's current team consists of the 4 co-founders. We have diverse expertise. Emilia specializes in microbiology and leads the bacterial isolation campaigns. Carola is a biotechnologist and leads the process optimization. I bring knowledge and expertise in the textile industry, and I'm responsible of the validation of our products. And Esteban offers a strong business and science background, leading the team strategies. This combination of expertise and knowledge allow us to translate the textile industry needs into the lab and science experiments and bring solutions directly to the market. A year ago, we were backed by Gridex. Gridex is a leading accelerator fund based in Argentina with operation across all America. Since then, Protiva has become an established company, and all of us now work full-time on this mission. Okay, we expect to finally develop our brown color to the end of this year. We are also developing a black pigment to an isolation new bacteria to produce blue, red, and yellow to finally produce a complete trichromy for the industry. We have a methodology developed with the brown color that is scalable and repeatable to all the next colors. First, we start with the screening platform, amplifying our portfolio of bacteria, selecting the best production candidates. Then we enhance and optimize the production cost. Then we run trial in textile mills with industrial scale-up to finally unlock each color in a production level and make a trichromy. We have a question, right?
Yeah, there is a question.
Okay. If the dyes are chem-enhanced, does this not impact on waste items? Do you have any comments on the acceptance of the waste as safe for disposal by environmental authorities? Yeah, of course. Thank you, Dr. Grafan, for the question. We are using this green chemistry approach, and we are not using any chemical, for example, of the certification zero hazardous discharge, blue sign. We are focusing on these certifications to work. So we are designing the molecule from this approach. So the acceptance, we are already thinking in that before the wastewater effluent. Okay, so that's it. I answer your question.
Yep, Gonzalo, you can go ahead.
Okay. Okay, so these are our next steps in this road, and we know we can't do this alone. So if you feel engaged with Protiva's vision and you are passionate about making the textile industry greener through biotechnology, we would love to talk. First, we are eager to meet technical advisors, especially those with experience in textile chemistry, pigment structures, or application processes like dyeing and printing. As we are in early stage, few slots remain open to partner with brands and mills for pilot trials. This means testing our products across real textile conditions. It's a great chance to co-develop and validate a technology that's aligned with real sustainability goals. And finally, we are also connected with investors who bring more than just capital, those with industry networks and share long-term vision. We are looking for active partners who want to help scale a new generation of sustainable dyes and create global impact. We believe Protiva has a global long-term vision, and to execute it, we also need people on the ground who understand both the technology and the market dynamics. We understand the current situation is not just an opportunity for Protiva, but a chance for the entire industry to lead the next revolution of colors. The question is, will you join us? Thank you.
Thank you, Gonzalo. Dr. Arun Patra, do you have any questions from the audience or from yourself?
I don't see any questions from the audience. One question was asked by Dr. Graham Clayton, which has been answered.
Yeah.
I would first of all thank Mr. Gonzalo for the nice presentation. It is interesting. And although natural dyes have been there for a reasonably long time, but your specialty is you derive these from bacterial source, right?
Exactly, yes.
So, but right now you have got only brown color. You're yet to develop other colors. Am I correct?
Yeah, exactly.
So how is the market capitalization like? Because for a coloration industry, you have to have complete gamut of colors. And right now it's only brown. So how do you address that?
Good question. We have a lot of conversation with Mr. Yogesh also about this, because, for example, for the brown color, there is a huge market in bottom, for example, for pants.